Welcome to my lecture. Today we are going to solve one trigonometric problem from the International Math Olympiad 1962. The problem states that solve the equation cosine square alpha plus cosine square 2 alpha plus cosine square 3 alpha is equal 1. To solve this problem, we need to recall few basic trigonometric identities which you might well know, but to have a complete answer, we recall some basic identities. So cosine 2 alpha equal to cosine square alpha minus 1. And then cosine alpha plus minus beta will be cosine alpha cosine beta minus. If it is alpha plus beta, then it will be minus. If it is alpha minus beta, it will be plus. Then sine alpha sine beta. And then sine 2 alpha equal to sine alpha cosine alpha. This is all are needed. Maybe we need few more. We'll see that whenever it's required. Now reformulation of the problem. So it was given that cosine square alpha plus cosine square 2 alpha cosine square 3 alpha is equal 1. So from the previous identity, cosine square alpha, you can write it 1 plus cosine 2 alpha over 2. Then like this 4 alpha means double the angle, and then it will be 6 alpha. This is equal. Follow the red, which follow the color which we make it accordingly. Now this, if we simplify, so you will have cosine 2 alpha cosine 4 alpha cosine 6 alpha is equal minus 1. Now for our purpose, we rewrite it 2 alpha as 4 alpha minus 2 alpha and 6 alpha equal 4 alpha plus 2 alpha. From here you can have any other method or any other way you can express it, but this will be maybe more easy one. Now we extend it to cosine A minus B and cosine A plus B formula, and we'll see how it will come. So this we extend it. So this one is plus sine 4 alpha cosine 2 alpha, and for this one is minus sine 4 alpha sine 2 alpha. And then these two will cancel out, and the rest is we have left with cosine 4 alpha cosine 2 alpha cosine 4 alpha cosine 2 alpha. So it will be become like this: cosine 4 alpha 2 cosine 2 alpha plus 1. This is equal minus 1. Now we'll take this cosine 4 alpha to the half angle. So cosine 2 alpha. So this will be 2 cosine square alpha minus 1. Sine 4 alpha can be written as 2 cosine 2 alpha minus 1. And this is as it is 2 cosine 2 alpha plus 1. And this is equal minus 1. Now we extend it and we will get a cubic equation. So get it 4 cosine to the power 3 2 alpha 2 cosine square 2 alpha minus 2 cosine 2 alpha minus 1. And this minus 1 and minus 1 cancel out, and we can take out cosine 2 alpha from this whole equation, and then we have this formulation. So cosine 2 alpha 2 cosine square 2 alpha plus cosine 2 alpha minus 1. This can be further factorized. This expression can be further factorized, and we have here in this form. So cosine 2 alpha 2 cosine 2 alpha minus 1 cosine 2 alpha plus 1 is equal 0. So therefore each of the factor possible cases we need to find out 0. So we will take divide from here 3 cases, and 3 different cases we will have. So first we will take cosine 2 alpha is equal 0. So when cosine 2 alpha is 0, the first direct solution is 2 alpha equal pi over 2, and then this implies alpha equal pi over 4. But if you take the generalized formula, general solution with due to the periodicity of cosine function, so this will be x equal 2k plus 1 pi over. So for k is 0 plus minus 1 plus minus 2 and so on. So this is plus and minus. This will be for also for plus, minus, plus, minus, and so on. Okay, so this is the first solution we have, case 1. Now we move to the case 2, and case 2 will have cosine 2 alpha is from this factor. Cosine 2 alpha is equal minus 1. So from this factor we have cosine 2 alpha is equal half, and then from there we will have 2 alpha is equal pi over 3, and then or 2 alpha equal 5 pi over 3. So two cases possible, pi over 3 or 5 pi over 3. And then from there we get a general solution, means alpha equal pi over 6 and 5 pi over 6, and then we have the general solution is x equals 6k plus 1 pi over 6 from this part. From pi over 6, it will be 6k plus 1 pi over 6 due to again the periodicity of cosine function, and then x equals 6k plus 5 over 6. And these two are the solution, and k is equal 0 plus minus 1 plus minus 2 and so on. Now come to the third case. Here is case 3, cosine 2 alpha equal minus 1. So this will give us 2 alpha equal pi and alpha equal pi over 2, and then general solution is 2k plus 1 pi over 2, and same way k is from 0 plus minus 1 plus minus 2 and so on. So this